Hi, Gabe. We were all wondering where you are. So, we know you're on vacation, but we don't know where, and we need more information because we miss you. All right, here we go. Hello. What? Just drop us your home address and your social security number. Here we go. So, when we take a definite integral, we are integrating over a set of bounds. I can't write like that. Integrating over a set of bounds. Okay. So let's talk about what an indefinite integral looks like. That's going to be where it's just the squiggle, no numbers at the top or the bottom, something like this. So if you integrated this, your answer would look like a function, right? With a plus c at the end. Because that function belongs to a family of functions where the vertical shift would drop out if we differentiated. Okay? Did you get a haircut? Oh. Oh. You can't see her hair because you're not here. But it looks really good. So then, now if you have a definite integral, wow, Miranda, way to make it creepy. Okay, so now we have from 1 to 2. Notice how these little numbers cropped up. Those are called bounds, okay? The number on the bottom is the lower bound, and the number at the top is the upper bound. We talk about lower and upper as we scan across the x-axis, right? That's what we mean by lower and upper, okay? So if we integrated this thing, right, we would end up getting a number, just a plain old number, with no c. We're going to talk about the implications of an answer like that. We'll show you. We'll show you. Okay. So let's look at example number 1. You want me to show you? Here we go. So I have 5 times e to the x dx. When I integrate something like this, I end up with 5, right? He's a constant. He could either get pulled out front or you could just leave him in the integral. Either way, it's just 5 times at the end, e to the x. And then he's being integrated from the ln of 2, which is the lower bound. Don't forget, ln of 2 is just a decimal.
Do we have to draw the bracket?
Up to 3, you do. This is how you evaluate a definite integral. So you integrate, you have your little function there, and then you draw your square bracket. Lower bound goes on the bottom, upper bound goes on the top. Then you could do one of 2 things with a constant. I find the math, when you're doing it by hand, is the easiest if you keep the constant out here, and then you do your upper minus lower in parentheses, because the constant's going to get distributed or multiplied at the end anyway, so, okay?
Right. Okay.
So in here, think about it. In the place of x, we now have the upper bound minus the lower bound. Where did the e come from?
The original.
Yeah, this guy right here. The 5 went over here. And then now the upper bound is going to go here, and the lower bound is going to, I don't really have space. It's going to go here. Yeah.
Oh, wait, I'm just going to let it play out.
Yeah, let it roll. Okay, so then now.
If you put 5 in there, would it just be 5 to the 3rd minus 5?
Yeah, doesn't matter. So now you have e to the 3rd minus, what's e to the ln of 2? I don't want to let the parentheses freak you out, right?
2, period. Period.
Okay, so then now if I wanted to distribute, just so I have everything in terms of one thing, 5 e to the 3rd minus 10.
Is that our answer?
Yes. Do you notice that there's no c? In fact, this is equivalent. Connor was not even left in the car. He was left in Wegmans. He wasn't even in the car. So this, if you typed it into your calculator, is 90.427, something like that, right?
Okay, this doesn't end up answering my question because I let it play out. But so do we say this was like an actual?
Hold on. I feel like this is a good question, but some of us aren't listening. Now,
if
go ahead.
This was like 2x. Would we do x? I don't know how to.
What's 2x? Who is 2x? Show me.
Like say instead of a 5 to the 5e to the x, replace e to the x with 2x.
Like this?
No.
No, replace
E
the
the
x
x.
with
Like-
the x.
Like 5 2x.
Or just 2x.
Yeah, just 2x.
Yeah, would that change? Like, would we do the f of x version of that?
So if you integrated, it would look like that. Right? Is that what you're asking
No,
me?
with the bounds. He's saying with the bounds. So like it would be 2x.
Is he saying with the bounds? Are you just asking me if you're integrating with a different looking function?
Like, because e to the x, its original version
Is the same, right?
Yeah.
That's why I picked it as my example. It's the easiest one because it's like,
so
oh,
it
we
does
just
change
did
when you do
this.
something else, though.
Yeah. Let's look at the next one, okay? Is that what you meant,
Yeah.
Eleanor?
Yeah, it was just like, what was like, what if I was integrating, and it definitive integrating 2x.
Yeah, I wanted to keep the integration as simple as possible, so I picked an E. We're gonna do some more where there's like polynomials and stuff down below, okay? All right, so this represents something graphically, okay?
Oh.
Oh. We're gonna learn over the course of the next couple of days what it represents exactly. So let's go in our calculator. Yes, it is the area under the curve. Good job. So let's go in our calculator and we're gonna practice how to check these, okay? I don't think you guys did this yet. So it's in a different spot on your calculator, but if you go to the lobster,
Are we on to graphs?
no, you're on a calculator page. And then mine happens to be all the way to the right in the second row, but yours might be in a different spot. It looks like a integral symbol with a box on the bottom, a box on the top, and then square, d squared. Like
Oh.
this.
Oh boy.
He's got it.
I'm like,
This guy's
what's
got
this
it.
one?
This guy got it.
Help. Jack, help.
So now what you're gonna type in is what's written over here, okay? You got ln of 2,
Yes.
3.
Yes.
Precisely. We all found it.
Yes.
Congratulate us.
He swore. You hear that?
What?
He did.
Did
Gabe heard it.
Did he?
Did he?
Gabe, did you hear that? Let us know.
He's,
So if you wanted to check and see if your answer was right, because you're probably going to get something that's in terms of ease and all that, you would just type it in. And you're like, yeah, it's the same. Woo. Okay? Pretty straightforward, right? Let's do another one. Yes. All right, so here. We've got, he's on vacation at his house. Gabe, are you on vacation at your house? Hit us back.
I texted him, he hasn't responded yet.
He's having
So,
fun, did he, or not?
Let's envision what's going on right now. I have a constant up top. Could I rewrite this as,
I think
could I rewrite this as this, do you guys think?
That's entirely possible.
For sure, right? Because if I multiply fractions, I can do numerator times numerator over denominator times denominator, and I could do the
X
reverse
plus 1 to
too.
the negative 1 though.
I'm going to put the 2 out. That's what I wanted to do. Good job. The reason why I did this is because I wanted to do this. Let me, like, put this in your brain. If you have something like this. If you have an integral that looks like this, you cannot, don't even write this down. I don't want you to even get confused for 1 second. Do not write this down, just look at the board. You cannot break up multiplication
I did that.
like this. Can you just put it in your brain that you can't do that?
Yeah.
You can only break up things that are being plus or minus. Okay?
Got it.
Then why can you break it up as it's being divided?
Well, you're not breaking it up. You're rewriting it as an equivalent form. Right? Just like if you had x squared times x plus 2. Okay, I can't break it up, but I can totally distribute this, and now I have something that I can work with.
Or can you put x squared before the squiggler?
Well, now I can break it up because it's separated by a plus and a minus.
Like, never mind.
Can I factor out an x?
Yeah.
No, you cannot.
Then
Good
why
question.
Can you do that with this one?
It's a constant,
Not an X, Jack.
not an x. These are good questions. People do these weird things. I'm glad you're asking me. Okay, so now, if I wanted to integrate this one, right? What do we know about 1 over a plain old function? We're not going to use u substitution because the derivative of this guy would be 1, right? It wouldn't be helpful to us in any way. But we do know that 1 over something
X.
turns into an ln. Good job. So we have 2 times the ln of, don't forget, the absolute value of x plus 1. So that's my integration. I have my 2 out front, and now I just multiplied him, right? And then my bounds of integration will be from 1 to 2. Okay. So now I'm going to put that 2 out front here, and I'm going to do the ln of, and then these are both positive numbers, so I'm just going to put in parentheses, okay? But I have the ln of upper minus the ln of lower. Okay, you guys see where everything came from?
Yeah.
Okay, and then you can distribute through. Oops. Where's, hold on, let me write, because I keep messing up because I'm writing and listening. What?
Oh, I
Two
get it.
ln.
Never mind.
Oh, okay.
De-ask.
What's de-ask?
I'm de-asking.
De- removed.
What did you say? What did you say, Jason?
That was Jack.
He said TSPMO. What does that stand for? Would you like to tell us? We already know. We already know.
TS
Okay.
doesn't stand for this S word, by the way.
So,
Yeah, it does.
yes, it does.
Yes, it does.
That's when it's not with PMO though.
No, you say this. It's just this shoot.
Nope.
Piss me off.
No.
This salami
No, it's fine
pisses
with
me
PMO.
off.
You don't watch enough Instagram.
What about
You don't want to-
checking your answer? Do you think you would be able to check this? Easy peasy? Cool. Let's move on to the next one.
Wait, hold on.
Hold up.
Sounds like someone's constipated.
Never mind.
Miranda, I'm sorry that happened to you. Okay, let's look at the next one. In the next one,
I'm not liking it.
I've got 2 things being multiplied together in the denominator. Let's distribute them and combine their powers. So that way I could just get a singular power of x. How does that sound? Sounds good? Sounds good? Okay.
X.
Oh, I got a response from Gabe. I got a response from Gabe. He's in Florida.
I didn't mention.
Thanks, Gabe. This is so meta. I can't believe we're talking to you on here and in the phone.
That's the universe. That's the place that's on Earth, right? That's on Earth. I don't know what else.
All right, so do you guys see what's going on right here? We rewrote this as x squared, but a smart version where I could add the 2 powers together and get a singular power of x.
Yes. I see it.
So I would get 1 over x to the 5 over 2. Can you rewrite that for me so it's easier to integrate?
X of negative 5 over 2. Okay.
Yeah? Yeah. Okay. Let's integrate.
No.
5.
What does it say at first? Is it 4 over 2? Yeah, it's 4 over 2.
4 over 2 times x to the 1 over 2. All right, so let's integrate this. Or wait, hold on. We're integrating. So I'd have negative 5 over 2. So let's think about adding a smart version of 1 to that. What would I add to it?
2 over 2.
And I would get negative 3 over 2, right? And then,
Alright.
because you have negative 5 over 2 and then you add 1. It's still going to be negative. It's not enough to be
Negative
positive.
2x.
Now, I have to divide by the new exponent, okay? I want you guys to start getting used to this method so that way you don't get like bogged down by the calculations, right? So if I divide this by negative 3 over 2, that is the same
put the 2 up
thing
there.
as multiplication by negative 2 over 3, or the reciprocal, okay? And this kind of helps you like not get stuck in the math, okay? So that's like a little shortcut you can use.
Is the game not
So
doing
then,
that?
what?
We've been doing it the whole time. The game
Yeah.
over here.
The get. Oh,
Yeah, we're all
yes.
Jason taught us the method.
Yeah.
Yes.
I'm like Gandhi. You know that?
In
Wow.
what kind of way, though?
You know that I have a special affinity for Gandhi because in 2nd grade Or what grade was it? I don't remember. But we had to dress up like a famous person, and I wore a swim cap, and I popped like the glasses out of an old set of glasses, and I dressed up as Mahatma Gandhi. Yes.
He was the Indian guy, right?
He was. Like, can you think of anything more humiliating? No, but it's fine.
What did he do? The Indians?
He led the Indians to peace.
He did know.
Oh wait.
Yeah, he was like all civil disobedience and all that jazz. Yes, he was a leader. All right, so I've plugged it in, but maybe if you're like me, you're like, this is quite a bit of calculations. Let's think about what it's really asking us, right? Yeah?
Jason's a fan of him.
Okay,
I'm
so
a big
what's
fan.
the negative 3 over 2? Whoa.
So, let's rewrite this as fractions. That helps us. Here, I'm going to go up here. Negative 2/3 times. Okay, let's envision 4 to the negative 3 over 2. Well, we know that something to the power of 3 over 2 ends up being 4 times the square root of 4, right? Do you guys remember that?
What are we talking about right now?
Okay, so what we're doing currently is this. Because we have to do it by hand, right? This is a 2, sorry. And then what is anything with a base of 1? 1. Okay, so let's figure out how we would do this by hand, right? Okay,
No.
so I have negative 2 over 3 times 4 to the 3 halves. If I kind of split that up, right? Inside of 3 over 2, I have 2 over 2 times, or here, let's do it, 4 to the 2 over 2 times 4 to the 1/2. Can I decompose it like that? Is that okay?
Sure.
Yeah, right? Then 4 to the 2 over 2 reduces to what?
4.
Okay. And then what's the square root of 4?
2.
Okay, you with me now?
Over 8.
All right, cool.
Why is there's the 1 there?
Because anything with a base of 1 is going to end up being 1, no matter what power it's raised to.
Oh, maybe.
So we were just like, cool.
1.
So now I have 1 over 8 minus. Can we rewrite 1 as a smart version of something that we can combine with 1 over 8? Are you guys okay? Yeah, okay.
Okay, girl. Isn't agave the Mexican?
Oh my gosh.
Hey, my
Tequila
dude.
plant?
guy. I got
Blue agave is the Mexican tequila plant, and then agave is a sweetener. All right, so how did we do? Well, we turned this into a decimal here. We typed in the original integral here.
Solid part.
Are they the same?
So like on a test,
Yeah!
simplify it that much, we would get 7.
What?
So on a test,
Sammy, do you say yes? What?
Stop it. Simplify it that much to get 7/12 or what
Boom.
You're never usually just calculating an integral. You usually have to use it for something afterwards. So you probably want to put it in the easiest to work with version. You probably want to put it as a fraction because you probably have to do something with it.
Would you have your calculator on this question?
No, that's why we went over figuring out the radical. Okay, good questions. Let's go to 1. 1 is over here. Are you ready? 1 is easy, right? Let's do it.
I like this guy.
Dang!
So let's integrate. Let's integrate. Why do you look suspicious? Are you okay? No? You are suspicious. Oh, I don't want to know that.
He's
Okay.
he's
Oh
constant.
my god. Why the upside
I think I
down?
might have this exact breakfast in my height.
Yeah.
Yeah?
I made it.
Nice. You guys ready? Go ahead, hit it. Try. See how you do.
Wait, look what that seems. I got a little too shy.
Hmm?
Yeah, here, I'll give you my laxatives. Like, negative.
Now, not to be graphic, but you guys do know this is being filmed.
Oh, yeah, game, let's go.
What happened?
Me and Cynthia were talking about fun times.
They were talking about laxatives. Okay, if you got 4, good for you.
That's true.
If your soul has left your body like me, that's good too.
Can't wait to go to
Never mind. I don't think it's the exact question. Very simple.
Can you, like, post this, like, everywhere?
What? This video?
This conversation, like,
Yeah, I think that's finally how teachers get a raise.
yeah.
They're gonna watch it and be like, oh no. Okay. So what do I do for question number 2? Same thing, right? When you integrate a 3, what happens? You tack on a... Good job.
X, more like X. Get it?
XXX.
Yeah.
R.I.P.
Yo. Yo.
Are you guys speaking in Braves forever?
Braves. I'm brave.
What happened?
Are you going to speak in abbreviations forever?
R.I.P.
Hold on, this is messy. Hang on.
I don't know. TSS.
Salam Wallahi. But you know the answer.
More. I agree. I take whatever Jack says. I go by.
Actually, let's simplify this in the next step before we keep going. Okay, so I get 8 over 3 minus 6 over 1. What are we going to have to do in order to combine these bad boys?
Times 3 to the both of
Yeah, let's get a common denominator. And then I'm going to have to do the same thing over here.
I don't like this.
Uh-oh.
Uh-oh, spaghetti-o.
You're welcome. Negative 8 over 3? Would that be?
All right, now let's see. It gets a little funky.
I think it'd be 2 over 3. Negative 2 over 3. My apologies.
Oops, negative 10
This
over
one's
3.
So you go through it, you turn it like a, you simplify it as close as you can, and then you turn it, you substitute the x and then you integrate. So like the step of all this is you simplify it, and then you substitute the x in, not the x, it's like 2, and then
Would we
you
tell
integrate it
C?
after the fact.
Say that again in order.
So am I integrating it before or after?
You integrate before you do top minus bottom. Is that what you're asking me?
So I integrate before I sub in the 2 and the
Because otherwise you don't know what you're subbing in for, you know?
yeah, okay.
Okay, good.
I think it's negative 2 over 3.
Hey, stop. Come on, paper too. Nope. I see that negative
I can't. You're trying to do math.
All right,
10. I got the answer.
cool.
Connor got the answer.
Anybody have any questions? You see what kind of skills you're going to need to brush up on? Simplifying radicals, getting common denominators. That's probably about it. We okay with that? What?
Where's the kickball at?
Yeah, we're kickball.
What is it, May 15th? May 15th we finally get kickball?
Yes.
That's got to be 100 days left of school.
No, I think it's just 100 days of meeting.
Does this look okay? I pulled out the constant. Can I do that?
I don't like it.
Me neither.
No.
I like
Well, you
it,
can if you want.
but I don't.
All right. Personally, I do not do that. Oh, so now we have this. We're going to add 1.
I'm on a bird and I want
3 over 1 times. Okay, what is 3 over 2
2 over 3.
when you, good job, when you divide by it? Yes. So what's going to happen with these bad boys then?
2.
Yes.
2x. 3 over 2.
And then what are the bounds? 1 to 4.
6x.
4 to 1. TSP.
In this case, we didn't factor out the 2. You totally can. I'm just showing you like what would happen if you didn't, because we did it like 3 times where we did, right? You're just going to get the same thing. Yeah. Yup. Very interesting. Very interesting,
I
huh?
think it's 14.
What is it? Oh, 3 over 2.
Is
Okay.
it not?
So what do you guys think? 4 to the 3 over 2. Didn't we just figure that out? Yeah.
Is it 14? So it is 14.
And then 1 to the 3 over 2 is always what?
Like this, just this one.
Well, it is,
No.
no, but wait.
Times the 2. Yep, you got it.
How is 4 to 3 over 2? Yeah, I want
We just figured it out, but we could go through it again, right? So you got, hold
I
on.
think it's 6.
4 to the 2 over 2 times 4 to the 1 over 2,
6.
right? This becomes a 4 to the 1 because 2 over 2 reduces to 1 times the square root of 4.
okay. So you
Yeah.
multiply.
Yeah.
So is 14 just the answer? Like, is
Yeah.
That's it?
That's it. Okay, so definite integrals have an answer that looks like a number. Indefinite integrals have an answer that looks like a function. Good job. And there's a plus Connor at the end, your favorite. Okay. So I want you guys to open up to your formula booklet. You could always intuitively figure out what the integral of cosine and sine are, or you can look at your formula booklet. Sort of, but you have to consider the signs a little bit, right? So go look at your formula booklets. I want to know that you guys know where to look. It's 5.10, I think. Yeah, one of the last things you gotta
Jason's
learn.
not looking.
I'm looking. I'm really looking right now.
So as you look, I'm going to sing to you, as I always do. The derivative of sine is
Negative sine.
the derivative of cosine.
Negative sine.
Okay, so if you ever are trying to think and you don't have your handy formula booklet with you, right, and you have the integral of cosine,
Sine.
what's that going to look like?
Sine.
Yeah. And then if you have the integral of sine dx, what's that going to look like? Notice how there's no minus in this guy. So what's he going to be when you work backwards?
Negative cosine.
Yeah. Okay. All right. You could also just look it up in your formula booklet. Up to you. All right. So I've got 0 to pi over 2 cosine of x dx. So first we integrate. What is the integral of cosine?
Negative. Or the sine. Negative
Regular sign, right? Because the derivative of sine is cosine. So if I'm working backwards, it's just plain old. I'm still singing sine.
Sine. Sine. Sine.
What's the sine of pi over 2?
I don't know.
Oh
wait.
Nothing.
1.
No,
Yes.
it's 1 over 2, I think.
No, it's 1.
No,
3
check
over square
it.
root 2.
Check. No. Oh my. Oh my.
Whoa!
It is 1. Yeah. That's why I was like, yeah.
It's 1, 2,
But how did Jason figure that out? This is pi over 2. Unit circle, okay? X is cosine, X is cosine, Y is sine.
Straight up 0. What are we doing back here, boys?
The answer is 1. Okay. We feeling good?
Heck yeah!
Good, because it gets so much worse. Okay, turn your paper over. Yes! As always happens in this class. Here we go. Okay. So you have the basic skill down. Let's talk thinking. Okay. So we have given the integral of f of x from 1 to 3 is negative 2. The integral of g of x from 1 to 3 is 3. And it says find the integral of 3 times f of x minus g of x from 1 to 3. I'm going to do the second part. These are like 2 different questions, okay? So I'm not doing this one right now. I'm doing this one right now, okay? So let's look at which clues match the bounds that we have been given. This clue matches the bounds that we have been given from 1 to 3. And this clue matches the bounds that we have been given from 1 to 3. These do not match, so we're not going to be looking at those for this question, okay? We are now zooming in on these. Okay. So if I'm trying to think about when I integrate f of x, right, I get an area of negative 2, or I get an answer of negative 2. What's 3 times that?
Negative 6. This isn't bad.
Minus, and then what is... when I integrate g of x from 1 to 3, what is that worth?
3.
Okay. All right. Yeah, so you're just thinking. You're just using rules of integrals. Okay?
You hyped this up like it was
Yeah.
bad.
You could see this in a table form, kind of, or like this. But either way, it's just clues and inputs, okay? So, 1... Let's think about it like this. Here's another representation. Instead of just doing it again the same way, let's think about it like this. Check it out. I could put the 3 out here, and then I can split them up because they're pluses and minuses. Check this out. Do you like this way too? Yeah, right? This really matches up to the clues up top now. So 3 times negative 2, which is up here, minus, and then this guy is matched exactly right here. Okay, was that a good little alternate representation there? Okay. Now let's look at the next one, okay?
Hold on. I think
I want you to be a code breaker in the next one.
Like the Navajo.
Look at the question. We are integrating f of x minus g of x, but from 5 to 1. Now, when we integrate, we scan from left to right.
I agree.
So if I'm switching now, and the higher number is coming first, how do you represent a reversal in math? How do you a negative, right? So if I have to switch the bounds, good job, so they match intuition. If I have to switch the bounds so they match my intuition, I need to put a negative out front. Okay?
yes.
Cool. So then now I have f of x minus g of x dx, okay? So let's look up top right. What's f of x minus g of x? What is that going to end up being? Huh?
Oh yeah.
How's he gonna do it? He doesn't have the paper.
Oh my. Gabe, do you hear this? Everyone's very concerned about you.
He's gonna print it out.
Yeah, were you
Just
okay?
engine.
Okay? I'm just matching the clues. And then I put this in a little note over here so you can remember. Okay? So kind. All right. I hope you're okay with this because we are moving on to something called. Can you read the title for us? Somebody read the title for us.
Can't do it.
Connor, read us the title.
Definite integrals with U subs.
Okay.
That's like the Germans, right?
You only. Yeah. Okay. So when you are using U substitution in a definite integral, you have to do it this following way. Okay? So, two things need to happen. You need to have a definite integral, so you need to have bounds, and you need to be using U substitution. Can you evaluate a definite integral without U substitution? Yeah, we just did like 6 examples, right? But some structures of the integrals lend themselves to we need U substitution, okay? So, let's look at this one. Usually your clues that you're going to be using U substitution are, they look sketchy. This is a sketchy looking integral. It looks like I'm going to have to do some thinking, right? I also see a clear inner function here and an outer function. Composite function, U sub, okay? So let's kind of write this so that way the dx and what it looks like is more intuitive, right? So I would do this. I would put a 1 over this. And then I would put the dx over here. And then now I'm like, okay, I got a better idea of like what this thing looks like. Now, I see a clear inner function of 3x plus 1. I'm going to let my u equal 3x plus 1. Therefore, my du is going to be 3 dx. Is there a constant of 3 present in the original
Divide by
integral?
3.
No, we divide by 3. Good job.
1/3. Oh.
Okay. So now, this is the most important thing you are learning today.
No.
If you were making noises or meowing or whatever it is this class likes to do
That's Jason.
prior, lock in now, okay?
We know what we're doing.
So, you take the lower bound and you take the upper bound. If you're going to write the original integral in terms of u, what must you also do with the bounds? Put them through the same transformation that you put all the other stuff through, okay? So, you take the lower number of 0, and then look what happens. You take the u, and you put that 0 through the same transformation. Okay, so make sure you know where this came from, because I'd say this is probably the number one thing kids forget is like, oh, how do I change the bounds with the u and not have u's, right? He kind of goes in where the x was, right? You're putting all the x's in terms of u's, you're going to put the bounds in terms of that.
I got it.
So now you got 0 plus 1 is
How
going to be
clever.
1. How very clever. Let's do the upper is 1.
3 times 1 is
I saw approximately 4.
According to your calculations. Okay. Good job. Good job pretending to hang in there for a few seconds. Here we go. Now let's write this guy in terms of u's, okay? The lower bound, the new lower bound is what?
#1.
The new upper bound is?
A little bit of a 4.
Okay, now you try to write the integral in terms
What
of
about
u
the
here.
1/3 in front?
We're doing it when we do it like this. Okay, so we go.
Or you could write that. It's you.
Okay.
Ooh, like soldier.
So if we're gonna
I did it first.
if we're gonna integrate u, we're gonna go ahead and rewrite the square root of u in a denominator as u to the -1/2, right? And then we're gonna integrate. Sound good?
Hey,
He said it.
first.
You said it, bro.
Either 1/2 over 1.
Come on, dude, bro.
I'd say the more methodical you can work, the better. Like, try not to like work quick, do shortcuts like that. When you do those in with these, you're gonna mess up, right? So now I have u to the no.
Hey, you see
All
that?
right, we get it, we get it. What?
Oh yeah, bro. I forgot
He
about
sees
that.
it now.
I see it now, bro. Can't stop me now. I'm ahead.
Jason's too cold with it.
Ooh, it's cold in here. Jason, show it.
Okay, if my new exponent is 1/2, what am I supposed to do?
Divide by 1/2.
Divide by 1/2, which is the same
And
as.
multiply by 1/3.
Times 2.
Okay, and then now there is a 1/3 out front, yeah? So I've got 2/3 u to the 1/2 evaluated from 1 to 4. Isn't this so nice? We put everything
It's
in terms of
so
u,
nice.
so we don't have to deal with this crud anymore. It's
Whoa.
so easy,
Oh,
right?
calm
We
down.
don't need
Come
to
on,
do
I have
anything
feelings
else.
too.
We just put in the lower bound, or the upper bound minus the lower bound, and we have our answer, okay? So that's the beauty of the u. It turns scary things into easy things, and then since we changed our bounds, we don't have to do any other sort of conversion. We're like good to go, okay?
Why do we have to change our bounds?
Because if you put everything else in terms of u, you gotta put your limits of integration in terms of u as well.
Okay.
Good question.
Okay. Okay, hold on.
2/3.
That's what I got.
Okay. Yay, our last example.
No!
Ever?
For the
Yay.
rest of your life, Gabe.
Yeah. Oh.
Bye,
No.
Gabe.
Diddy's gonna get him for you.
You think my pen's alive yet?
Yeah. Save. We gotta save Gabe. We can get Diddy.
No.
Yeah.
No. Sorry, Gabe. We had to write on the board because my pen died. We're gonna see if it's alive now.
How come they charge so fast?
All right.
They don't have a very good battery. They just like
So,
use very good battery to give it.
what is different about this one?
Yo, the M, bro. The M, bro.
There's an m, so we have an unknown bound, and it's equal to what? It's equal to a thing. So that means we're trying to solve for an unknown of m, right? Okay. So let's see how we would do something like this. Just trust your gut, right? You're going to integrate. Let's integrate. Let's simplify. What are our bounds of integration? 0 to m. And then whatever we end up getting from here needs to be equal to
5.
5.
I agree.
So let's set it up, right? I've got m squared plus 4m minus. A lot of times when 0 is the lower bound, and there's just a lot of times when 0 is the lower bound, the second part drops off. Not always, because there might be constants in there, but just know that like if this happens, it's totally fine. It happens a lot. So now you would get 0 squared plus 4 times 0. So now I get m squared plus 4m equals 5. What should I do to solve this? Do you know what my algebra kids love doing? They love doing this at this stage in the game. Does that make any sense whatsoever? I'm sorry, I'm just filled with rage and I need to tell someone about it. Okay, so what would you do in order to solve this? Subtract a 5 on both sides.
Square root it. What's the square root of 5?
Yay! Yes! Yes, good job. It's quadratic.
Man, I think you might.
Wait, could I have a negative answer? Yeah, totally. It's fine. Yeah.
You weren't ready.
Okay.
It's all have a big box. I win.
I'll win.
Yeah,
Yeah, this
I would win.
How could you check your answers?
Wait, see,
By plugging it in, bro.
Yes. I know what you're going to ask me. Yes. Yes, you're paying attention. What?
well,
Oh, maybe not. Maybe not.
It's one.
Never mind. Yeah, Jack.
-5 can't be the upper bound.
It can be, but what happens?
It doesn't work. It doesn't work.
It's less than 0.
How do you know?
Because it's
Less
less
than
than
0.
zero.
I can do.
Because it's not lower than 0.
That's not more than 0.
Can I do this?
because at the top,
Yeah, well, that's not end that.
Can I do that?
You could, but that's not end. End's on the bottom of that. And that's not what we have. We need 1.
Can you expel Connor from the class?
What?
Free my boy, he ain't done. Spell him. Get him out.
this is disgusting.
You don't have to do this by hand. I'm just proving to you what happens. You could just like watch or whatever.
I'm watching. Yeah.
Oh, because you make it negative.
What?
You're too slight.
So sneaky. So this is why it's okay if you get a negative, because you can just switch the bounds, because it's the opposite, okay? What am I doing? Hi. Oh, ha.
Freaking. Don't touch my butt.
Well, I mean, you probably put it in the 50.
I just.
No, you won't.
But, so, I looked.
Wait, hold on. This is 25. Yeah.
So,
Four answers, technically. You can have none of them.
Was that equal to 5? Do you see what I mean by if you have, they're kind of like improper. You want to think about them as improper, right? You switch the bounds, you negate the outer area, and it all takes care of itself, yeah?
No.
Okay, so I'm not proving the other one because it's going to take a lot of time, but we're going to type it into our calculator and prove that we're right, okay? Let's go ahead and check. If they're both right, let's go ahead and check. I wanted to show you that the negative works. And you could just type it in like this. Your calculator does the math for you. If you type it in, if you type it in the reverse order, the calculator does the switch and negate for you. You don't have to switch it. Oops. Okay, if I'm right, my answer is going to be
Hey.
yes.
Hey.
And then let's change it.
Strawberry cream.
Dream, not cream. Dream. It's a dream, not a cream.
I drink
Okay.
What?
Wait, hold on. Hold on. What? Hold on. I'm thinking of something.
What are you thinking?
Oh.
20 questions. Let's put 20
It's just gonna tell me the first answer, but I want to know if this will tell me. I want to see if I can do it.
-5. Actually, no. I believe it'll just give you 1.
Wait, let's think. We know that when we do end solve, we have to solve for a variable. So what is this guy solving for?
9 plus 10.
I know. So like this isn't like mathematically correct, but I do want to see if it's gonna tell me just to mess around. If it's gonna tell me what the first one. All right, so it's gonna tell me the first positive. Interesting.
Basically, what it does
Okay.
is they
Don't. This is not recommended. I was just kind of messing around, and I just wanted to see what would happen.
Basically, the way the end solve works is that it basically goes from like 0 to positive infinity.
Uh-huh. First, and then it does negative?
Yeah, then it goes from like
You even count.
Well, it doesn't give you two answers, though, does it?
no, I can't.
If there's no positive, it will go to negative. I see. Okay, cool. Gabe, don't do that. I was just messing around.
Let me try.